Now here's something you might expect. Python works really well with numbers. Python actually gives us several different types of numbers, depending on the kind of value you want to store. One of the most common is called an integer, often referred to as int in Python. Integers are just whole numbers. They don't have any decimal points. Think of values like 5, 42, or -7. Let's take a simple example. Suppose you want to track how many books you've read this year. You could write books underscore read is equal to 12. This variable is storing an integer value. And if you want to check what type of data this variable is holding, Python lets you do that easily using the built-in type function. So let's see how that is done. Print type books read. This will show up what type of value this variable is holding. Now, class int. When we run this code, Python will print something like class int. This confirms that the variable books read is storing an integer. Now try creating your own variable. Let's say you create apples in basket is equal to 15. Now we want to print the type of this variable. So type apples in basket. Now you should get the same result because 15 is also an integer. Integers are whole numbers, positive or negative, no decimals. Use type function to check what kind of data your variable holds. Variables like books read is equal to 12 are storing integers. Now, there might be times when you don't just want whole numbers, but numbers with decimal points like 4.5 or 99.99. In Python, these are called floating point numbers or simply floats. To create one, we can do something like this. Temperature today is equal to 27.8. This is a float value. This variable temperature underscore today is now storing a decimal number. To confirm this, we can use the type function again. So, print type temperature underscore today and you'll see the output. Python is great at doing maths, just like a calculator. We can do basic operations like addition with the plus sign, subtraction with the minus sign or hyphen, multiplication using the asterisk or star syntax, and division with the forward slash. Now let's try a few examples. Now let's say we give print 3 plus 7. So we get the output 10. Then print 15 minus 4. And we get the output as 11. Then print 6 asterisk or multiplication sign 9. This gives us 54. And then let's try a division. Print, we give 25 divided by 5. That is 5.0. But did you notice something? When we divide, Python automatically gives us a float, even if the answer looks like a whole number. This is because Python converts all the integers, that is whole numbers, to floats before performing a division calculation. Now, let's try dividing by 0. So, print 10 divided by 0. See, Python just threw an error called zero division error. So always make sure the number you're dividing by is not 0. Next, let's look at the order of operations. Just like in maths class, Python follows the same maths rules you learned in school. Now let's see, print 4 plus 3 multiplied by 2. Now what is the output? The output is 10 because the multiplication happens first. That is 3 multiplied by 2 is 6 plus 4 gives us 10. If you want Python to add first, you can use parentheses like print 4 plus 3 multiplied by 2. So the output now becomes 14 because we have given parentheses for the addition to happen first. Now we can also use variables in calculations. We can also store values in variables and use those in our maths operations. Now let's look at the example. Let's say we take price is equal to 150 and let's take another variable discount and give it a value 40. Now the final price is equal to price that we had minus the discount. Then we want to print the final price. Now let's see. Let's run this. So we are getting the answer as 110. Now if we update the value of price, everything updates accordingly. So now let's see. If we update the value of price as 200 and now when we run the program, all the calculations are updated and we get 160. The variable discount still holds the value 40, but since price changed, the result also changes. Now let's do a quick recap. Integers that we learned are whole numbers without decimals. Floats are numbers with decimal points, for example 4.5, 99.99. We can use addition, subtraction, multiplication and division for arithmetic operations in Python. And Python respects the standard math order, that is BODMAS and PEMDAS. Variables can store values and we can use them to calculations. Now that we have covered the basics of arithmetic, that is addition, subtraction, multiplication and division, let's explore 3 more powerful operators in Python that we'll often use when working with numbers. Starting with floor division. Let's say we are organizing students into teams and you have 16 students. Each team must have exactly 3 students. So how many full teams can you make? If we write 16 divided by 3, that gives us 5.33333, which means we have 5 full teams and a bit left over. But in this case, we don't care about the leftovers. We only want complete teams. That's where floor division comes in. It rounds the result down to the nearest whole number. So, if we give 16 floor division 3, the output is 5. We can think of it as give me only the full parts and forget the rest. Next, we have is the modulus operator. Now, what if we want to know how many students are left without a team? That's where the modulus operator comes in. It gives us the remainder of a division. So, 16 modulus 3 gives us 1. So, one student will be left out after creating 5 full teams of 3 people. Now, let's try another one based on our earlier reading example. Pages read is equal to 80. Now, if we give pages read modulo it gives us 3. So if we were tracking our reading progress per week, that is 7 days, we would have 3 pages overflown after distributing them evenly across the entire week. Next we have is the exponentiation. Lastly, if we want to calculate powers like squaring or cubing a number, let's say we are tracking the video views and they are growing exponentially. We can expect them to triple each day for the next 3 days. You can use the exponentiation operator to calculate. Now let's say we have views on day 1 is equal to 10. Then the future views we are expecting to be views on day 1 multiplied by 3 raised to the power 3. 3 to the power of 3. Now we want to print the future views. So we get 270 as the output. Now we can also simply do 8 exponentiation operator 3. That is 8 raised to the power 3. That gives us 512, which is also similar to saying 8 multiplied by 8 multiplied by 8. So these three operators, floor division, modulus operator and exponentiation operator, expand our arithmetic toolkit in Python and make our programs smarter and more efficient. So far, we've explored integers and floating point numbers, and we have stored them inside variables and even performed basic arithmetic with them. Now let's look at something really handy. That is, how to quickly update the value of a number stored in a variable without rewriting the whole expression. So Python gives us a shortcut for this using something called as the plus equals operator. Now let me show you what that means with a fresh example. Imagine we are tracking the number of pages we have read today using a variable called pages read. We start the day reading 30 pages, so we give it a value 30. Now later in the evening, we read another 50 pages. So instead of writing pages read is equal to, then again writing pages read plus 50, we can simply use pages read plus equals operator 50. Now let's print it. Print pages read. Now you will get 80. It's a neat way to increment a number stored in a variable. Now, just like we used plus equals, there are other shorthand operators also, like minus equals, then we have multiplication equals, then we have division equals. Minus equals is for subtraction, then multiplication equals is for multiplication, and division equals is for division. Now, for example, if you wanted to halve the number of pages you've read, you can do pages read division equals 2. Now, let's print it. Print pages read. So, we get 40. So, this makes your code shorter and cleaner, especially when you're working with counters or you're working with accumulated values.